We begin question answer session on mechanics, and it is lecture number 3. The first question coming up. A particle of mass m moves in a central force whose potential is V, which is a function of r, equal to kmr cube, where k is greater than 0. Then energy for which the orbit will be a circle of radius a about the origin is, and the options are as follows. Option A is half mka square, option B is 3 by 2 mka square, option C is half mka, and option D is 3 by 2 mka cube. The answer: consider a circular orbit of radius r along which particle of mass m rotates. Force balance equation is central attractive force equal to centrifugal force. Let us consider the central attractive force part. It is vector F equal to minus dv dr into r hat. Taking modulus, we have F equal to dv dr, and it is equal to ddr of kmr cube. Upon differentiating, we have 3 kmr square. Again, the expression of centrifugal force is mv square by r. Equate to get 3 kmr square equal to mv square by r. M cancels out on both sides, or v square equal to 3kr cube. This implies v equal to r into under root 3kr. Now at r equal to a, v equal to a into under root 3ka. So kinetic energy will be, we know, half mv square. Put the value of v to get. And this simplifies to 3 by 2 mka cube. So the answer to this question is the option D. Let us switch over to the next question, and it is as follows. The mutual potential energy V of two particles depends on their mutual distance r as V equal to a by r square minus b by r, where a is greater than 0, b is also greater than 0. If the particles are in static equilibrium, then their separation is, and the options are, option A is 2a by b, option B is a by b, option C is 2b by a, and option D is b by a. We come to the answer now. For static equilibrium, dv dr equal to 0. Putting the expression for V, we have ddr of a by r square minus b by r equal to 0. This implies, upon differentiation, minus 2a by r cube plus b by r square equal to 0. This implies r equal to 2a by b. So the answer is option A.